At this point in our journey of developing an optimal schedule, it is time to discuss a couple of popular techniques related to resources. As the project manager, your goal is to make optimal usage of resources while scheduling. Resources are always in short supply, and there are several common problems that you will face while assigning resources to the activities. Resources can be people, machinery, raw materials, or even budgets. You will often find that critically required resources are shared among different projects, so you have to plan the work according to their time availability. Or there may be a limited quantity of resources available, so you cannot deploy as many resources as you want to. In other situations, the same resource might be required to perform multiple tasks at the same time. Apart from these, there are many other domain-specific resource issues that you will face in scheduling your project. In this lesson, we will discuss some techniques to resolve these issues. Most resource problems will show up on the schedule as an overallocation. In this slide, I will first explain what an overallocation is. It's extremely important to understand. Later, we will see a technique to resolve it. On the screen, we have a Gantt chart representing a small snippet of the schedule. There is a problem hidden in the schedule model. Let's observe this diagram a little closer. Notice that there are three activities: Activity 1, Activity 2, and Activity 3. Activities 1 and 2 run parallel on the same day, that is day 1. Activity 3 is dependent on these two activities and runs on the next day, that is day 2. If you observe here very carefully, you can see the problem is that Beth is assigned 16 hours of work on one regular 8-hour day. So you can see Beth is assigned here and here also. This is an overallocation where a resource is allocated more work than they can handle. Unfortunately, this type of issue is very common in design, and it can be due to a simple oversight, or more likely it is due to any other issues that I mentioned in the previous slide. Next up, we will see a technique to resolve this issue. One popular technique to resolve the overallocation is called as resource leveling. And you can see the solution on the screen here. First half of the screen shows the problem that we had earlier, and this half of the screen shows how it has been resolved. The same schedule has been resolved. Activity 2 has been pushed to the next day, thus relieving a resource Beth. And as a result, the overallocation has been resolved. The common side effect of this technique is to change the original critical path of the schedule. An extra day has been added up here to the schedule in this example. You can and you should make use of any available float while you use this technique. This example may look very simple, but in real-life projects with hundreds or thousands of activities to manage, it will be very difficult for you to detect and resolve such situations optimally. And this is where modern scheduling tools like Microsoft Project will make your life very easy. The built-in algorithms of Microsoft Project will take into consideration the critical path, the slack on individual activities, and the slack on the total schedule, and different types of schedule calendars. We will study about it later to determine resource leveling. I urge you to take a couple of minutes and study this Gantt chart and the technique to become familiar with it. The next technique that we see is called as resource smoothing. This technique is not used to solve overallocations like in the previous technique. Rather, this technique is used in situations where resources have predefined assignment limits. For example, some contractor working on 10 hours a week, some such situation. Another example is when a critical resource can only contribute a few hours per week. then you will want to schedule around their availability. Another situation is when you want to ensure your team members are distributed with equal work. In these situations, you will use resource smoothing. Resource smoothing is exactly the same technique logic as resource leveling, except that we will take care not to impact the critical path. Tasks which are not on the critical path are adjusted in resource smoothing so that their floats can be used. This technique might not give you optimal results, or it might not solve all the problems, but this is understood and it is acceptable. And with that, we come to the conclusion of this lesson. Resource leveling is used in more critical solutions, for example, when you have overallocation on the critical path. The resolution for resource leveling usually involves manipulating the end dates of the entire project. Resource smoothing, on the other hand, involves manipulating end dates of individual activities and not for the entire project. Both these techniques can and will be used in tandem. In the next lesson, we will look at a different scheduling technique called as what-if analysis. So, I'll see you in the next lesson.